All right. Hi, guys. So my name's David Campbell. I'm an application specialist with the PPI Group. All right, so I've got just a little brief outline of what I'm planning on covering today. Now, before I get started, can I take a general consensus? Who here is structure kind of focused? Awesome. So with that, would you say you're leaning more towards, or can I get a show of hands, who here is more towards structural steel? 1, 2, 3. Okay, so a few. Mostly concrete then? Yeah? Okay. All right. So I'm going to concentrate a lot today on like structural steel, but I do have both data sets. I can kind of go back and forth in between concrete and structural steel. Okay. So with structural connections, with I think it was like the second updated 2018 into 2019, they gave us the structural connections, right? 2019 and into now 2020, we're starting to see that we can customize those connections like we haven't been able to before. I mean, yes, you can make plates, adjust your bolt assemblies essentially, or their layouts, but it's also, I mean, just creating your own, specifying your welds, creating side plates or stiffeners, web stiffeners, flange stiffeners, specifying all of this while you're just designing it out. And then being able to essentially group all of those elements together into a connection, okay? And what's really cool for Revit 2020, without giving too much away, I guess, is the fact that they've started integrating Dynamo into what Revit does in terms of generative design. Now, I went to the Autodesk conference in Denver a few weeks back, and their focus, actually right now, they're focused on mechanical and structure. Okay, so they have big focuses on mechanical and structure right now in terms of getting Revit to where it needs to be. All right. So with that is that generative design that you're going to see. I'm going to show this off a little bit today with what's called Propagate connections. Okay. But I'm also going to show you how to annotate these steel drawings. We'll go into a little bit of preparing loads, talk about the forces, where you can combine your loads, placing these loads, whether it's line, area, point, and they're hosted, things like that. And then we're going to kind of talk about the export to robot for structural analysis, or really the structural workflow from Revit into, let's say, robot for an analysis, then back into Revit to make your adjustments, and then if you needed to, into advanced steel for either advanced detailing or any fabrication assemblies that you need, okay? There we go. All right, so a little bit about the structural steel, like the industry profile, right? The commercial BIM industry, a lot of it looks at the factories, the warehousing, mid-rise offices. These are typically projects you're going to see for structure, right? Healthcare, the education, the high-rise towers, and the stadiums. We also have, though, the chemical plant processing, power generation. I mean, the list kind of goes on and on. And that was the industrial connection kind of industry, construction industry there. Now, we also have our bridges, the highway bridges, architectural, pre-engineered buildings, and this year in 2020, they've given us the capability to actually run rebar through our precast stairs. So that's kind of nice that they're integrating that as well. Now, with the precast, okay, or the concrete kind of industry, it's extremely varied with the range of products that we're seeing. Many are not linked to, you know, AEC. Parking garages are going to be most of the common projects that we see, as well as the mid and high-rise commercial BIM. And many of these are actually on an early BIM adoption kind of curve. And then you're going to see that there's been a huge improvement in our kind of concrete industry in the past 10 years. And in terms of the styles of buildings that we're putting up with these parking garages, you're going to see tilt-ups, which are pretty fantastic. When I was back in Indiana, I saw them doing a lot of the factories, or a paper mill actually, with a lot of tilt-up panels. It was pretty neat to watch. And then the rebar detailing. So this one actually has been a pretty big focus for Autodesk as well within Revit for the past few years. Not just through, you know, generating detailing rebar and saying, okay, yes, I have a rebar set or varying rebar, but now it's integrating that generative design into that rebar in terms of if I have a ramp that's following my parking garage and I know it's all precast, if I want to run bar through that, I can actually just pick my host surface, tell the start, tell the end, what shape of bar do I want to use and what type of spacing am I looking at, or do I want to go ahead and specify, and it'll run it through there, the whole thing for me, okay? It'll follow the shape of the concrete and everything. It's pretty fantastic. So this is what the typical kind of workflow is looking like. Now, I'm not going to death by PowerPoint here with you guys. I will be demoing quite a bit of this in Revit. But basically, this just talks about that workflow, right? So we're generating our design, we're doing our design changes, everything like that, modeling within Revit. It's when you go into Robot for that analysis in terms of, yes, I'm going to place my loads, or I'm specifying this is a 6-inch slab, and I'm putting it over a 10 by 22 beam. Okay, and I'm going to put my forces, either dead load, wind load, snow load, what have you, on there. I want to see how it's going to react. Or maybe it's a retaining wall, and I want to see what the force against this retaining wall, if I need to actually run, let's say, cages on the face and the or front and back side of each parts of that wall. What do I need to do to secure it? That's where Robot's going to give us that analysis to show us what's happening, so we can make those design changes and bring it back into Revit and make a smarter design. Right? It's not really until the end that you're seeing that we can take it into advanced steel for any of the advanced detailing that you really need to do, or if you have assemblies that you need to go ahead and send for fabrication. That's where advanced steel is really going to shine. All right. So this is another kind of note about that workflow, right? Construct, analyze, detailing, and then generate. So without further ado, here, let me switch over to the star of the show. Okay, so in Revit, I'm going to show you guys a couple different connections here real quick. But first off, let me start by saying structure or steel. Either way, the structure tab or the steel tab is going to give you these structural connections, okay? It's when you get into the steel tab that you see you're going to start being able to customize these connections or create your own types, right? Now let me get into this one. I'm going to show a little base plate here. See if I can get into entry level. There we go. See if I have any metal columns. No. All right. Let me go back to this one. There we go. Do the same thing. All right. So what I'm going to do here is I'll end up showing you guys how to create just a regular base plate, okay? I'm going to start off with just drawing a plate here, and I'll show you how to group these together, and then I'll also show you about the default connections. Actually, let me go ahead and show those first, I guess. So to bring in the connections, you actually have to go into your connection settings, which is going to be here or under the Manage tab, okay? This is what's going to bring up your library of structural connections, which thankfully are loaded in with Revit 2020. This is all brought in. It's not a separate add-in that you have to bring in. All right. Takes a second to come up here, but if I leave it under all connections, this can get a little overwhelming, right? I have all my apex haunch, my base plates, my bracing, the double eaves, the gusset plates, what have you. What's really nice about this, though, is I can start essentially filtering this down based on the types of connections I think I'm going to need, right? So if I have a column to beam, there's my beam seat, column beam seat, excuse me. I'll grab a seated beam connection and a stiffened, right? Grab beam end to end, no. Now I'm going to grab a base plate here. Okay, so when we're ready to place our connection, we can do is go ahead and specify connection, choose the connection type you're trying to use, and then essentially pick the members that you want to go ahead and connect. You'll hit enter. Now I held down control there to select both of those elements. And what you'll see is Revit will automatically generate this base plate. Okay? Now, I'm going to try to see if I can get it to reset here so it'll show it to us. It's got a small base plate there. All right, there it goes. So we have our nice base plate, right? It generated it with a default 4-bolt pattern. Now, here's where it kind of gets fun. Now, this is a default connection, right? You'll see right up here, we can customize this. We can also break it if you want to start to kind of add other things in. But first, let me start here with this customization. Oh, you know what? No. You're not giving me the modify parameters, so I'm going to go into edit type. Usually what you'll see is the modify parameters here. This is where you're going to go to edit the actual properties of this connection. Mine's wanting me to go to edit type, so I'll go ahead and get it there. All right, so in the connection type like dialog box here, you're going to see your base plate, like the overall layout. Do you want to change the thickness, whether it's the layout projections total from center or from your anchors? Do you want to have your column shortened based off of that plate thickness or a value that you specify? When you go ahead and connect these together, it essentially like copes the bottom of that beam to bring it to the face of your plate. Okay, the base plate dimensions. If you want to change that, your corners, do you want to go ahead and fillet those, the anchors, the holes, or like I said, the welds. We can specify what size of a weld you want to use. Do you want to use a fillet, a back, bevel, flare, any of that type of stuff? And then you can also start specifying whether you want this done in the shop or in the field. Okay? The stiffeners and the plates, same kind of thing. Leveling plates, shim plates, all that type of stuff. This is where you're really going to focus on customizing the layout of this connection, right? And when you're done adjusting it, that's when you hit that customize button to name your custom connection. It's almost like a duplicate kind of thing, duplicate and rename. You're saving it to your library. So, also with those holes, there we go, galvanized, grout, punch marks, anything like that. All right? And then again, after you're done making those changes, you can go to customize. It's pretty much save as or duplicate. Okay? So, that's one way to do that. The other way is if you want to go ahead and draw it yourself. So if I come in here, plate, okay, I'm going to tell it to draw. Just like any other Revit modeling tools, we have our temporary dimensions here. I'll go ahead and call that good. All right, now, what I need to do is go ahead and specify my bolt pattern. So I grab my bolts, say I'm going to put them on my plate there, and from there, come on, there we go. From there, it's going to ask me what type of pattern do I want to draw them in, a rectangular or circular pattern. So I'm going to go ahead and grab a rectangular pattern. There we go. Okay, so 4-inch gap. All right, and then here's also where I can specify the information for my bolts. Do I want to use the standard EN 1439 or 39.9, or what type of bolt do I want to use? Do I want to change the grade of the bolt, the diameter, the assembly? Do I want to galvanize it? Do I want to coat it? Anything like that. You can even give out and specify the exact length of the bolts, everything. Okay? And from there, you can grab both of these down, and then we go to, let's say, what I'm going to end up doing is grabbing what's called a generic connection here. So this is what I need to make between my column and the column below here. Okay? Once I make my generic connection, that's when I'll go ahead and essentially customize this to include both of these elements into that connection. All right, and then from there, I can use that connection moving forward, name it whatever I need to. All right, so those are the two ways to essentially create or place your connections. Now I want to show you guys something cool here. 3D. All right, so I'll essentially connect one of my beams here. Grab the connection. Beam seat. Come on. There we go. Okay, it'll take a second to generate. Oh, nope, doesn't want to do it. So, that's a good thing there, right? You guys see that little yellow triangle there? That tells me that connection does not work. This connection is not going to work there, okay? So I need to adjust it. I can go ahead and choose, which I only brought in my beam seat here, I guess, so I'll need to grab a different one. But, come on. Let me delete that out of there. There we go. You bring in other ones here. But once, that's the one I wanted, that clip angle. Once you've actually brought it in, you can adjust it and change it to whatever you need. Pretty much, go up to steel, connection. Let's go with clip angle. Okay. And it'll take a second here to generate for us. Now, you'll see it copes that beam automatically, right? And it's still kind of working its magic here. It's moving a little slow this morning, but, oh wait, I'm still in medium. There we go, fine. So, you have to be in fine view in order to see these connections. Also, as another note, when we're going to detail these, you have to be in wireframe. That will allow you to go ahead and grab to the center of your bolt or the center of the holes or the outer diameters of your bolts and things like that, okay? Now, since we're talking about this earlier here, grab this connection. Okay. So, I have my my nice little connection here, right? Come here, come back. Gosh. There we go. Filter, check on, structural connections, cool. What I can do with this is when I right-click here, you'll end up seeing, where'd you go? Propagate connection. Why aren't you popping up for me? There it goes, propagate connection. So this is new for 2020, propagate connection, right? What this does is essentially looks around the entire model. Now this one's going to be dumb. I should have done it in a regular 2D view. This one's going to take a few minutes. But what it does is it reads the entire model or view that you're in for any connections that are just like this one. Any like conditions. So if a beam is joining into another beam just like that, it's going to go ahead and associate this beam seat that I placed, or the clip angle, I'm sorry, the clip angle that I placed here on any other connection in my model. And as I said, though, it is either view specific, so if I did it in a 2D view, it would go ahead and associate that just in the view. Because I chose to do it in my 3D, it's going to try to do my entire model for me, okay? And it will do it at one time. I think there was like 488 connections when I did this yesterday. I mean, just generated like that, okay? So that's pretty cool. I'm going to switch over back into my PowerPoint, though, because I had something here for you guys, this one. So this is another this is a video that I'll show you here. But this is just showing you some of this power, the power that Dynamo is bringing to us within Revit for these structural connections. So we have these user-based rules, right? And it's kind of noting the propagate connections there. And what you can do, as he said, as he just showed there, is you can start associating different members to these connections. So if I know all of those columns that are going to have those base plates, I'd put them on. My apex haunches. As soon as I'm ready, I can go ahead and associate that and just check out how it reads them, right? It doesn't put the connection on every one. It only puts that connection on where it is viable or where it makes sense. All right. So, I mean, that's just, I think that's pretty awesome. being able to have it automatically just generate connections for us based on what it's reading. All right, so that one was pretty cool. All right, let me back out this, and then I'll come back into Revit here, if she wants to open back up for me. All right. Cool. So I'll zoom out a little bit, and it's kind of done doing its thing, but right now what I'm going to see is that all of my connections are there. They're going to take a few, like, I'd probably say 2 to 5 minutes to actually generate, to show the bolts and the plates and everything like that. It's still kind of processing that in the background, but it's going to let me navigate through my project, and you'll see all of the connections here. Those are those connection symbols right there. All right? But any view that I go in now is going to have those connections there. As long as I'm in that fine view, I'll see them. All right. So going back into my ground floor, did you guys have any questions on those connections before I move on? I'm going to go into like placing loads and things like that now. Yes, sir. When you propagate the connections, it's making adjustments based on size. So is there any type of connection that it finds that it's like it's going to create adjusting for the size? Yes, sir, exactly. Yeah, it's going to adjust those plate depths or the flanges and everything, but what it's going to do is associate the same number of bolts, or try to. Okay. I think it's still trying to place those connections. All right. All right. So, as we get into our loads, those are all going to be under the Analyze tab, because I mean that's really what we're going to end up doing with it if we're utilizing this. Now, I haven't seen a lot of utilization here, but I kind of believing as we get further and further, or Autodesk is developing more and more structure into Revit, that maybe we will eventually get to the point where this is going to be very useful. So to get our load cases, or to actually start specifying what you're going to place, this is when you get into your cases and combinations. So when I click on my cases, it's going to bring up my typical loads, right? Dead load, live load, my wind, snow, the roof live, any seismic activity, things like that. It's pretty awesome. Actually, Robot runs very nice analysis for seismic and everything like that. Now, the load combinations is where you can go to actually start combining these together, generating your formulas to go ahead and pull those loads together. So when you're specifying it, it knows what it is or where it's going when you're placing your different forces, whether the X, Y, Z, what have you on it. Excuse me. All right. So when we're ready, essentially what we're going to do is go into our loads. Now, the funny thing is, you notice what's underneath here, analytical model. So Revit has two models for us, anyways, for structure. You're looking at the regular 3D model, but then we're looking at the actual analytical. So here I have one already made. So what you're looking at is when we place any structural member inside of Revit, it automatically generates an analytical member for that as well. You'll see each of these that I click on, they're still beams, they're still columns, everything like that, they're just analytical, okay? So when I go to place my loads, this is really where I'm going to end up placing them, because this is what Robot is going to read, okay? Now, it's not, I also want to specify that this is not just like the structural steel type of stuff. You're placing concrete walls, that is a structural element, floors, structural elements, anything like that, okay? And when you're going through, if let's say you've placed, I want to say modify sub-elements for your flooring, right? If you're placing drain points or anything like that, the thickness of your floor is changing, it's going to take all of that into account with the analytical kind of analytical kind of portion of that floor. All right. So to place these loads, I simply come up here to loads, And then I can choose, this is going to be a point load, line load, area load, hosted point, line, or area, okay? So if I wanted to choose my hosted line load, is this going to be a snow load, my dead load, anything like that? All right, so I can go ahead and grab one of these here. Start kind of placing my snow load going around that building. Very easy to kind of place them, right? Select all instances, visible in view, and here's where I can start applying my forces or the moments, right? So my forces could be, let's say, actually, what, 20? I think it is, yeah. Okay, so my load has been placed on that portion of that building. Okay, I can work my way around, placing all of my other loads on the building, and it'll kind of process it. And then when I'm ready, we would find my add-ins. Okay, actually, where did it go? Under add-ins, you'll typically find export to robot, okay? So we'll find export to robot, and that's how you'll go ahead and send that out. Now, when you're past that point, you bring it in, you make your adjustments, this is where you'll see the advanced steel add-in, okay? So we'll choose advanced steel, export that out, detail anything up as you need to, and you can re-import that back into Revit. All right. Did you guys have any questions on those, on placing those loads or the kind of analytical model for structure? Yes, sir. They will show up in Revit, yes. Now, they might not be parametric. They will show up back in Revit, though, yes. All right. All right. So I think, let me go back into the PowerPoint here. I actually do have a couple slides with, there's that propagate connections there. There we go. This one's robot. So essentially, as I said earlier, Revit has that analytical model, right? So we're looking at our actual 3D model here, and here's our analytical next to it. When you push that out into robot, this is kind of what it's going to look like after you're placing those forces on. It's going to show you how those surfaces are kind of warping. It's going to show you if you do have any deflection in your beams or in your concrete. It'll kind of show you exactly where that's happening. Okay, so we can make those necessary design changes. All right. Also, it can detect like code, so it can tell you if you need to size up any rebar, you need to change the number of bars, things like that. All right, so I won't go into too much with that one. All right, below that though, there we go, is the advanced steel. Okay, the advanced steel portion is where you're going to end up detailing these out in terms of if you needed a higher level of detail with your connections or the steel members, or basically if you're going to go ahead and send it out for fabrication. It can generate you a parts list showing you all your different beams, the cladding, the components, the bolts, all that kind of stuff, which of course now for 2019 and 2020, you can do that with Revit. Revit has built-in bolts and plate schedules. You can actually go through, break down all your connections and schedule them out or group them together, okay? And generate material takeoffs for those as well. All right. Let me show, actually, yeah. Did you guys have any questions for me at all, or any curiosities on anything else in Revit Structure? Mm-hmm.
Maybe, I mean, it's aside from the structural portion itself, but in the spirit of that, going back to basics, and we discussed a little bit about it last month, I think that sort of a refresher on best practices on the workflow, we've got a room with a lot of architects, a lot of engineers.
Yes.
The best practices of workflow of getting
Yeah.
that you would want to impart to the students. I think that's a worthwhile topic.
Yeah, definitely. Okay. So typically what I'll see is when you're starting a new structural project, you're going to end up linking in the architectural model. Okay. We'll end up going to, which, you know what, let me file, new project. We'll go with a structural template. So with this structural workflow, I'm just going to start in a typical structural template here. Come down to level 1. And this is where I'm going to end up inserting. I'm going to link Revit or link CAD. I mean, either way, you can utilize this. Now, I prefer linking Revit because it carries more information, makes it easier for me to model. Actually, let me pull from a different document set I have here. And I am in Revit 2020, by the way, for this demonstration. Yeah, there we go. We'll pull this one. So typically what I would do is pull in this architectural model, okay? After I pull it in, I'm going to actually copy and monitor the grids and the levels because I'm not trying to do that work again myself after somebody's already done it, right? And coordinating or monitoring that basically allows me to keep up if there are any changes in height. So I would have my top of steel, right? The architect's typically going to have the level. My top of steel generally is going to be 3-4 inches, I think 4 or 5 inches, somewhere underneath that level of the floor, depending on the thickness of the floor and everything like that. Okay. So I got to go into my Revit links. Brought it in as an overlay. Okay, so let's go into manage and then links, I guess. Manage links. Why aren't you showing? All right, so that one's not showing for me. Guess I'll bring in another one. After you copy and monitor, though, typically then it brings in, monitoring allows me to kind of keep track of any changes that are being made. Yeah, that's fine. Let's do that one. So I'll bring in a different architectural one. Now, as it changes, like I said, that monitor kind of keeps track of that. What I'm going to end up doing is I'm going to change my discipline here so I can kind of see what's going on here. I'm going to change it to coordination, right? And what I'm going to do is under collaborate, I'll go copy monitor, select link, grab this, and then go ahead and copy these over. Now, one big thing is I'm not really trying to mess with any architectural elements. I'm going to be looking for their architectural columns to place my structural columns inside of them. Or actually, depending on the placement of their structural columns, of course. I hit finish too soon, didn't I? Yep. Copy, grab these over. You got to hit your finish first, and then the green check mark finish. Okay, now here's where I can choose to monitor those grids, right? After we've done that, the same kind of workflow goes with our elevations. Once I've brought my levels in, again, it's going to go ahead and copy those over so I'm not doubling that work. So one big thing you'll notice, though, anyone work here with the plan views? Once you copy and monitor these levels over, they will not have a view associated with them. So you have to go over to make plan views and associate your structural views with those. And that's when you can go ahead and disassociate that a little bit, drop it to your top of steel. Or, if you want, leave those as architectural levels, right? So when those move, you can also constrain maybe your top of steel levels that actually have your structural views. You can constrain those to stay, and when the actual architectural levels move, they do as well. Okay, so that's kind of one way to do that. And as you're going through modeling for structure, I mean, that's when we're placing our either structural steel columns, or we're placing our tops of footings, or concrete walls, concrete columns, what have you, okay? Then from there, I would go ahead and probably on BIM 360 Design, push up this model and give the architect the rights to go ahead and view my model, right? So then they can link that in and they have an updated structural model, okay? And then just as it's going back and forth, that's where my model is living. Now, I'm not doing the whole everybody in one model kind of thing. I'm for live linking in the sense that I publish my changes when I'm done at a certain point. Like I'm at my 30%, I'm going to go ahead and publish these changes up, or even at the end of the week, every 2 weeks, what have you. Publish those up. That way they have all of the changes I want them to see. Okay? So the difference there is when you're going, I don't know if many people here work in BIM 360 Design yet or not with this workflow, is when you're going to synchronize. That's synchronizing on your local copy, right, in terms of where your company is hosting it. You have to publish, you have to publish that up to the cloud in order to actually, like for the architect or whoever else is involved in that, to pull that model and link that in and see those changes. So you can control exactly what phase of what they're seeing, okay? So then it would go back and forth from there. At least that's typically what I see. Okay? Any questions there?
Nothing that, I just kind of wanted to take it back to like the workflow.
Oh.
A whole lot has changed there. If I could maybe jump into the other extreme now, realize this doesn't be one of the things that maybe we can take a look at it, if you don't mind.
Yeah.
This is the other extreme. Some of the connections that you've shown, has anything changed in 2020 as far as detailing, annotation, shop?
Oh, yeah. Yep. Yeah, you know what? Actually, yes. So for concrete, there's quite a bit. With concrete, we have a precast tool. I believe I showed that one off last time I came. It actually has the capability to turn concrete elements into a precast kind of element where it'll build it out, give all the spacers, the plates, the bolts, everything like that in there with it. That one I do need to download into 2020. I probably should just get into 19 to show that. But we have that one. Now, for steel, if I go leave it in fine there and go to wireframe, this is where you're going to see we can start going through to detail. So I can snap to the center of my bolt here, center of my bolt there, and then take my dimensions. Yes, you would need advanced steel to do fabrication. That's really the big portion of where Revit is still kind of behind a little bit. They're trying to integrate more advanced steel into Revit year by year, but right now, yeah, fabrication is advanced steel, that level of detail. Okay. So also another kind of big note, though, is, let me get into this other one here. No, I'm good. I say that and then it crashes, right? All right, so here's where I have some rebar set up. Looks like an insulated concrete form or just a thick concrete wall here. I have a cage on the front and back of it, right? So with this, for 2019 and now 2020, you have the capability to go ahead and do a multi-rebar annotation, okay? It's really nice because it's able to kind of break it down as well for us to give us also our distance from the faces of any concrete or masses. So if I did have one in my, let's say in my actual set here that goes down into my footing, I would be able to go ahead and show how far that last bar is away from the edge of my footing. Let me go ahead. Yeah, that's fine. What are you doing? That's fine, I don't want to do that. There we go, I'm hitting the wrong one. There we go. Okay, so I can bounce up and do something like that, or, where was it? We have another one that labels it out. where's my tag? You go to tag your rebar this year. It's really nice on how it actually tags it. Now I need to adjust my units here to show in feet and inches. But when you go to tag it, it'll actually tag the entire rebar system. It'll give it what type of bar you're seeing, the spacing, and then if you wanted to, you can include that dimension of how far away you are from the face or from masses, okay? Also, again, when I go into, let's see, I get into my concrete floor here, that rebar, right? So if I wanted to go into detailing any of this, I mean, it's kind of insane how awesome this is getting, right? We can specify our cover, which is going to be the offset from the face of the concrete. That's your cover depth, okay? Typically, we're going to see, I think, like a 3-inch here. You can adjust that as well in your structural settings. You go into your structural settings. We have our boundary condition settings, but where is the cover? There it is, rebar cover settings. All right, let me just do this real quick. Good, good. Why it's still giving that to me then? Okay. All right, but again, with the cover there under structure, and then you go into the reinforcement rebar cover settings, this is just that offset, okay? It's going to give us from the face of that. So when I go to place them inside of this, it's recognizing it by that cover in terms of when I go to place rebar here, you're going to see that dashed green line all the way around. That's my cover, okay? So as I move down and around, it won't place it. But I can also specify the placement of my bar based off of that cover. Do I want it to run parallel to my work plane, or do I want it to run parallel to my cover? And then do I want it to run perpendicular to my cover? Essentially, what way do I want to run this bar? Okay. Now, again with this, it's kind of crazy because you can have it placed like this, and you can go ahead and say that I'm going to place a rebar set. This is going to go out throughout the whole length or distance of my footing, you know, anything like that. I can say I want a fixed number, maximum spacing, what have you. Or I can sketch it myself to create my own kind of rebar shapes. Or, you know what, let it run through it and do it itself through that free-form rebar. So with this one, let me go ahead and get into ground floor. Actually, let me try to see if I can get into. I want to be in this one, don't I? There we go. So I have my floor, okay? So I'll go ahead and just let it run some rebar through this floor. Go placement, freeform rebar, and you'll see this is kind of where it starts setting it up. Do I want to go ahead and follow a path? So this is nice if you have a curb or any type of wall that runs around like in those parking garages we were talking about earlier. Now I'm going to keep it with surface. I'm going to go ahead and select the host surface, which is going to be my floor, and then I'm going to go ahead and have it select. Okay, there we go, yeah. Start surface, right? So I have to select my start surface, which is going to be this portion of my floor. The end surface is going to be here, and then I can choose my layout. Now let's do number with spacing. Or let's just do maximum spacing, that's fine. And you're going to see it's going to go ahead and tell you pretty much exactly how many bar that you're going to get, but going to gray out here. It'll tell me that number after it's gone ahead and placed them in this floor. It's very nice. It follows curves. Like I said, it will actually just warp these around. If you have shafts, it'll cut the rebar for the shafts, everything like that. Surface is moving a bit slow after that other connections that we did. All right, and there we go. So my bar is divided throughout this entire floor. Go ahead. There we go. Actually, I'll just use that one. There we go. All right. So another kind of nice thing about the rebar here is when you get into the type or the individual properties here of the rebar, you can actually put workshop instructions on these. Do you want them to keep straight? Do you want them to bend the bar? The style of bar that you want to, or stir up or tie, of course, the style of bar that you want to use, whether it's number 4 or it's number 3, what have you. Do you want to put a hook at the start, at the end of them, the orientations of the hook? And this one's kind of a big one here, view visibility. So if you're trying to see your rebar in let's say, a 3D view, you want to show how this is running through a retaining wall and how it's cutting through, okay? You're going to need to go ahead and get into the visibility settings for that rebar here. And this is just going to say, do you want to view it unobscured from whatever element it is in, and do you want to view it as a solid? Here's where you choose the views where you do want to see that, okay? And you just check mark them, say okay, and they'll be visible in those views. I'll pretty much adjust like the transparency of the wall itself or whatever element is hosting the rebar to bring it out.
You still have to do something different for it to actually become a model element that exports in a 3D view for coordination.
No, yeah, all of these are, all of these are now model elements. The rebar is all, or should be. Oh, okay. Something like that, yeah. I mean, it's going to be there, but to export it, I would probably try to either, do a filter by view, filter it down to just your rebar or those elements, or unobscure it. Okay. All right. So really, I mean, the capabilities are getting better and better within Revit. And that, as I said earlier, with that precast tab, the precast tab is very nice for making any type of, well, let's precast walls, right? But what about a hollow core slab? If you have hollow core slabs, it'll actually go through and bring in a hollow core family and place the entire thing throughout your entire floor. It'll adjust the panels to size, and then actually what it does is it creates an assembly out of the elements that it precasts or makes, right? Then it generates those onto sheets, and it will place all of those onto sheets with a typical parts list. They're all annotated, and a material takeoff there for you. Okay, they haven't released that one for 2020 yet, I guess. So we'll have to grab that one. But do you guys have any other questions? No?
What's your workflow? Usually for us, engineers will model the modeling ramp scale, some kind of program.
Mm-hmm.
And then we'll go to us, and we'll kind of have to start from scratch. Some applications will take it from ramp scale, bring it over to there, and have it kind of semi-done, and pop back and forth.
Mm-hmm.
What's kind of the best case for working with
Well,
or best practices?
yeah, I mean, that one's hard just because when you're working outside of Revit, your design becomes disconnected. So you have to keep that constant track of what's changed so you can update it. I mean, Link IFC is nice for, which I think should be able to link those in, right? Those are the new 3D types of models. You should be able to link those in with that IFC. So it's nice. The only bad thing about it is they don't come in parametric at all most of the time when you're doing that. But with Revit, you have the pick line tool. A lot of times, if you guys do have line work that's coming in, or it does bring in a 3D model, if you can get into those individual views and utilize pick lines, a lot of time that's going to speed up your modeling process, I would think. And yeah, I'd say maybe try to just keep up with any changes when you do insert that link in, under Manage, you should have the like reload. So you go reload or reload from to make sure that you're keeping track of those changes, that your link, I guess, is the most up-to-date version. Yeah. Other than that, man, I'm not sure. Any other questions? No? All right, well, thank you very much, guys.
Thanks, David.
Thank you.